Salam and welcome everyone. So today we're going to be working on the question on the screen that says use the data from the research section to evaluate the difference Cp, m minus Cv, m in molar heat capacities for liquid ethanol at 298 Kelvin. So first of all, we have to break down the question. We're told to use the data from the research section. The first thing you have to note is that this book that we're using is Atkins Physical Chemistry 11th edition textbook. And at the back of the textbook, we have all of the data on how to solve questions from the book. And that, like, back of the textbook is called the research section. So we're told to use the data from the research section to evaluate the difference Cp, m minus Cv, m, where Cp, m is the molar heat capacity at constant pressure and Cv, m is the most molar heat capacity at constant volume. So we're supposed to solve for this. For liquid ethanol at 298 Kelvin. So we know that the temperature that we're going to be solving for is at 298 Kelvin. Now, the first thing you have to note is that even though they did not give us other parameters, when you look at the chapter where this question is in the book, we have to use the formula Cp, m minus Cv, m is equal to alpha squared times temperature times molar volume divided by Kt. Alpha here that I just wrote is just simply expansion coefficient, right? And then you have the Kt to be isothermal compressibility. So what this is telling you is that in order for you to determine Cp, m minus Cv, m, you have to find out all the numerical values for each one of the parameters. Now, remember, the question tells us to use the data from the research section of our textbook to determine this. Using the data from the research section of our textbook, the back of the textbook shows that for liquid ethanol, right, the value for the expansion coefficient is 11.2 times 10 to the power of negative 4 1 over Kelvin. So what this is telling us is that the unit for the value for expansion coefficient is 1 over Kelvin. Or you can just say 11.2 times 10 to the power of negative 4 per Kelvin. So that is basically it. And then you have the isothermal compressibility. You have the value, according to the back of the textbook, the research section, to be 76.8 times 10 to the power of negative 6 times 1 over bar. So the unit is just 1 over bar. And this is for liquid ethanol. So now we have the value for alpha, we have the value for Kt, we know the value for temperature because we're given in the question. The only thing we don't have is actually the value for volume. We don't have the value for molar volume. So Vm, we don't know what that is. So naturally, you're going to be wondering, well, we have two unknowns. We have the Cp, m minus Cv, m as one unknown, and we have the molar volume as the second unknown. But one thing you have to remember in chemistry is that the identity of the substance or the chemical, the molecule you're given, plays a key role in questions like this, right? We have V, molar volume, right, which we don't know. But we know that the identity of the molecule that we're working with is liquid ethanol, right? So this means that we can use our knowledge of density, which is density is equals to mass over volume, to determine the molar volume. And to do this, we have density equals to mass over volume. We don't know the mass, we don't know the volume, but doing simple mathematics, we can divide the right side of the equation by number of moles and the left side of the equation by number of moles. When we do that, mass divided by number of moles is simply going to give us what? It's going to give us molar mass, right? So mass divided by number of moles will give you molar mass because of the formula number of moles equals to mass over molar mass. So to determine molar mass, we do mass divided by number of moles. And then we have V, which is the volume divided by number of moles, which is just simply the molar volume. So looking at our work now, we actually have found another way to write the equation. So density is now simply molar mass divided by what? Molar volume. So you have the density here, which we know that since we know the identity of what they call it, identity of liquid ethanol, we can automatically know the density. So the density of liquid ethanol is just simply 0.789 gram per milliliter, as well as the molar mass, okay, of ethanol, of ethanol, Le, is just simply 46.068 gram per mole. So now we have that. So with this, now we can determine the value for molar volume. So rewriting this equation, we have molar volume is just simply going to be molar mass divided by density. So molar mass, we know that to be 46.068 gram per mole divided by density, which is 0.789 gram per milliliter. So you cancel out the grams, cancel out the milliliter, and what you end up with is 46.068 per mole divided by 0.789 per milliliter. And what you end up getting is 58.3878. So you have per mole here, it's just the same thing as saying 1 over mole. So I just want to make sure we have the right unit. So you have 1 over mole, okay, divided by, because of this large one here, right? Because we're focusing on just the units, divided by 1 divided by milliliter. Don't forget here that we've canceled out the grams, so we end up having the numerator to have 1 over mole as whatever is left of the unit for the numerator, and the denominator we end up having what's left of the unit to be 1 over milliliter. So that's basically what's going on here. So molar volume ends up becoming 58.3878. Okay, 1 over mole divided by 1 over milliliter is the same thing as 1 over mole, okay, times milliliter divided by 1. So that would be milliliter divided by mole. Okay, so that is what the molar volume is. Let's also not forget that milliliter, right, is the same thing as times 10 to the power of negative 3 liters, or times 10 raised to the power of negative 3 dm cube. So I'll rewrite the molar volume at the bottom. So molar volume becomes what? 58.3878 times 10 raised to the power of negative 3 decimeter cube. So that's basically the answer to this part of the question. Now let's not forget that all we found is the molar volume, right? We now have all the parameters we need to substitute into the equation, but then again, we are chemists. Many times our questions aren't just simple direct questions. They're going to require you to convert something to find other things, or do like 15 steps before you actually even start to substitute into the general equation. So that's the situation here. We see that the unit for isothermal compressibility, KT, is 1 over bar, right? 1 over bar. This is 1 bar is one of the units for pressure. But we also know that we're solving for Cp, comma m minus Cv, comma m. And the unit for Cp, comma m minus Cv, comma m is just going to be joules per mole Kelvin. That's what we want our final unit to be. But we cannot go with our understanding. We cannot use bar and just take it to joules, right? Or we cannot switch. So what I'm trying to explain to you right now is that we have to use a unit for pressure that works. And the unit of pressure that works in this case is going to be Pascal or Newton per meter squared. That's one. Now the understanding, we have to understand volume. Volume that we're given here, actually this is molar volume, so I forgot to say dm cube, is going to be dm cube per mole. So the unit for volume here is in dm cube, and the unit of molar volume is dm cube per mole. But just focusing on just the volume itself, we cannot use decimeter cube because we need our units when we substitute all of the parameters, the isothermal compressibility, the temperature, the molar volume, the expansion coefficient. We need our units to always match so that we can do the proper calculations. Just like you cannot divide kilograms and grams in the same question, you have to make sure they are either all in grams or all in kilograms. So in this particular case, we're going to make sure that the pressure, the unit for pressure, is going to be in pascals, which is the same thing as Newton per meter squared. So that is for pressure, okay? And then we have to make sure that the unit for volume is going to simply be in meter cube per mole, because you have meter here, I also have meter here. So that means we can do the calculation. So this is going to be the units for volume. So what this is telling us is that we have to go from bar, okay? So we'll go from bar to Newton per meter squared, right? And we'll go from dm cube to meter cube. And that's basically how it's done. So bar is this. We know that 1 bar is equal to 1 times 10 raised to the power of 5 Newton per meter squared, okay? And we also know that 1000 dm cube is equal to 1 meter cube. For those of you who don't know, let me just do like a short explanation. 1 meter is going to give you sorry, 10, so 10 decimeter. So if you want to cube it and take it from length to volume, which is just involving cubing, you have 1 times 1 times 1 will give you 1 meter times meter times meter will give you meter cube. And then you have 10 times 10 times 10 will give you 1000. Decimeter times decimeter times decimeter will give you decimeter cube. So that is what's going on here. So yeah, so that's basically how we got it. I don't want anyone to be confused. And if you've been watching my videos, I have over 95 videos for solving the questions in Atkins physical chemistry. And honestly, you would see me do this, what I just did, converting from decimeter cube to meter cube and meter cube to decimeter cube. I've seen it billions of times. I've done this in so many questions. So make sure you check out my playlist on physical chemistry. So we have this right now. Let's go and see what we're given in terms of bar. We have KT, which is just 76.8 times 10 to the power of negative 6, 1 over bar or par bar. So what this is telling me is that we're going to go from 76, okay, times 10 raised to the power of, sorry, 76.8. I apologize. 76.8 times 10 to the power of negative 6, okay? Par bar is the same thing as 76.8 times 10 to the power of negative 6 divided by 10 raised to the power of 5. So it's just going to be 76.8 times 10 raised to the power of negative 6, negative 5. So that would be 76 times point 0.8. I don't know why I keep forgetting that. Point 0.8 times 10 raised to the power of negative 11 Newton per meter squared. Oh, I apologize. No. It's not going to be Newton per meter squared because we've got Newton per meter squared here. So what this is telling us is because we've basically reorganized this, we have to end up with 1 divided by Newton per meter squared, which is just simply 1 divided by Newton per meter squared is the same thing as meter squared divided by Newton. Or let me just write it somewhere here. You guys should see 1 divided by Newton per meter squared, 1 times meter squared divided by Newton. So this is what is going to be. The new unit to just be meter squared per Newton. So yeah, that's just a quick one. So rewriting it, the new value for KT is going to be 76.8 times 10 raised to the power of negative 11 meters squared per Newton. So this is just basically this first part. So the second part, which is the molar volume, which we know to be this. Now we have to use this part of the molar volume, ignoring the per mole, which is 58.3878 times 10 to the power of negative 3 dm cube. We are going to substitute it and put it here to determine what that value would be in meter cube. So we have 58.3878 times 10 raised to the power of negative 3 dm cube equals to x. So you cross multiply. So you end up with x is equal to 58.3878 times 10 raised to the power of negative 3 dm cube times 1 meter cube divided by 1000 decimeter cube. So you cancel out decimeter cube, and then you have this x equal to 58.3878 times 10 to the power of negative 3 divided by 1000 will give you 58.3878 times 10 raised to the power of negative 6 meter cube. So that is basically this. So we have successfully converted the volume. So let's not forget that this is just the volume. Now we have to deal with the molar volume. So what we end up with is just going to be the molar volume is going to be 58.3878 times 10 to the power of negative 6 meter cube per mole is now the new molar volume. Now we have put everything in the units that we want for this question. So now we can comfortably substitute. So rewriting, we know that Cp, comma n minus Cv, comma m is alpha squared times temperature times molar volume divided by what? Kt. So Cp, comma m minus Cv, comma m is just going to be alpha squared. When we go back up, we see that alpha squared is 11.2 times 10 to the power of negative 4 1 over Kelvin. So the units is 1 over Kelvin. So that would be 11.2 times 10 raised to the power of negative 4, 1 over Kelvin, okay, squared times temperature, so times 298 Kelvin. That was what we're given in the question, times molar volume, which we just properly calculated. So that would be 58.3878 times 10 raised to the power of negative 6 meter cube per mole, okay, divided by kT, which is just the isothermal compressibility. So that would be 76.8 times 10 to the power of negative 11 meter squared per Newton. So we do what we do best. We cancel things out that we can. Cancel out the meter squared. We cancel out the meter cube. We just have meter left. Yeah, that's what we can do so far. So now we use our calculator to further simplify our work. So CPM minus CV, M. So we have 11.2 times 10 to the power of negative 4. Okay, 1 over Kelvin, all squared would give you 1.2544 times 10 raised to the power of negative 6. Okay, 1 over Kelvin squared. Okay, times 298 Kelvin times 58.3878 times 10 raised to the power of negative 6 meter per mole, divided by 76.8 times 10 raised to the power of negative 11, 1 over Newton. So you divide Kelvin and you also divide Kelvin here. So CP, M minus CV, M will just give you 1.2544 times 10 to the power of negative 6 times 298 times 58.3878 times 10 to the power of negative 6. So when you multiply everything in the numerator, you end up getting 2.182601 times 10 to the power of negative 8 meter. Let's not forget the meter here. Okay, let's not forget the mole. Let's not forget the Kelvin. So that would be meter per mole Kelvin divided by everything in the denominator, which is just 78, sorry, 76.8. I don't know why I keep making that mistake. 76.8 times 10 to the power of negative 11, and then 1 over Newton, 1 over Newton as the unit. So next, we input the information, okay, in the calculator, just the numerical values, right? We put all of this information, focusing on numerical values first. And when we do the division, we end up getting 28.4193. And then now we focus on the units. We know we have meter per mole Kelvin, okay? And then you say divided by, because of this huge division line, 1 over Newton, which is the same thing as saying 28.4193 meter per mole Kelvin times Newton. So you end up with CP, M minus CV, M to be 28.4193, okay, Newton meter per mole Kelvin. So that's basically the answer. Now let's not forget that Newton meter is the same thing as joules, because Newton meter is the units when you do the formula for work. Work being force times distance. So force Newton, distance meter, and then, of course, force times distance will give you Newton meter, which is joule. So this is joule per mole Kelvin. Just like I explained to you at the beginning, that we want to make sure we solve it in a way that we make sure our units are correct. And the units we want at the end of this question is going to be in joule per mole Kelvin. But our work is still not actually complete, because we have to put the numerical value in the proper number of significant figures, like you do in all chemistry problems. So looking back at our question, we see that we're given the temperature in 3 sig figs, the expansion coefficient in 3 sig figs, which is 11.2, and isothermal compressibility in 3 sig figs, which is 76.8. So when we put that knowledge, we have to put it in 3 sig figs. So our final answer, CP, M minus CV, M, is just simply 28.4 joule per mole Kelvin. So this is basically the answer to this question. Yeah, that's how you solve it. Please make sure you watch all of the videos on my Atkins Physical Chemistry 11th edition playlist. It is there to help you. If you have any questions, please put it in the comment section. I wanted to make sure to let you guys know that if you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, or college, I'm the tutor for you. I help students succeed in all your STEM related courses in middle school, high school, and college, doing courses ranging from calculus to differential equations to physical chemistry, thermodynamics, and quantum chemistry. So if you need help, please do not hesitate to email me at shaabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.